Hello, class. Today, our goal is to talk about the definite integral. So, reminder, up until now, when we've been talking about antiderivatives, we've been talking about indefinite integrals. So, we're going to jump tracks and talk about definite integrals today. And I'll warn you in advance that the way we're going to discuss this over these next few videos, that definite integrals are going to have nothing to do with derivatives. And so this is going to seem like something completely new and bizarre. And I promise we will tie it back to derivatives next week. Okay, so I'm going to start here with talking about what happens if my f of x here is a positive function. Okay, and by positive function, I just mean a function where all the values the function takes are positive, or in terms of the graph, if you want, the graph is always above the x-axis. So here's my graph of f of x. Okay. And so the notation for a definite integral is going to look a lot like the notation for an indefinite integral, except we're going to have two numbers sort of living on the integral sign, an a and a b. Okay. And so the way I can tell, again, that this is a definite integral is because there is an a and a b here. There are some limits, some numbers, whereas if I wrote just this with no numbers, this would be an indefinite integral, which is the kind we've been talking about so far. Okay. And so what is this thing that we have just sort of said how to explain? Well, this is an area. And what is the area of? Well, I go to the x-axis here and I find my a, and I find my b. And then this definite integral is the area of this kind of rectangle. So this thing is the area of this region. Okay, and I'll put an arrow there pointing at the region. Okay, so this region, if you want, it has three boundaries, or sorry, it has four boundaries. The a and b tell me the vertical boundaries. So this is just at x equals a and x equals b. We always use the x-axis as the lower boundary. And then the graph is the upper boundary. So whatever the function is, that's what's giving me sort of the upper boundary. And so this thing is almost a rectangle, except the top of the rectangle might be curvy. Okay, and so whatever the area of this thing is, that's a number. And then that will give me the value of this definite integral. And so I want to emphasize here, definite integrals are numbers. Okay. So I'm going to do a bunch of examples, and I want to remind you that so far we're only talking about positive functions, so functions above the axis. We're going to have to do something special, and we'll do this in the next video when we want to talk about what happens when the function is below the axis. Okay, so let's do some examples of calculating one of these things. So, namely, I'm going to start with something relatively straightforward. I'm going to start with the integral from 3 to 7 of 4 dx. And I'm going to encourage you for each example we do today to think in your head about what the graph is going to look like. And so this is going to be an important thing to do for the homework as well, is to think about the graphs. Don't worry, the graphs will be lines. So it will not be too difficult to imagine what the graph is going to look like, but you will have to graph lines. So the graph here is, well, in this case, I'm graphing the function 4. Okay, and this is a constant function, so the graph is just a horizontal line. So I get something like this. This is my graph of y equals f of x. Okay. And then I need to go ahead and grab my a and b. And so here is a, here is b. Okay, so I'll draw in. This is x equals 3. Okay, and all this being x equals 3 means is that this point here, that's the 3 on the x-axis. And I'll draw in x equals 7. Okay, and again, that's the 7 on the x-axis. That's all I'm saying here. And so then now I've described the 4 boundaries. So the x-axis, the graph, the left boundary, and the right boundary. And so I'm going to shade this region. And this integral is supposed to be the area of this region. Now, in this case, the region literally is a rectangle. In fact, how high is the rectangle? Well, remember, f of x is 4. So that is to say that this is the distance between y equals 4 and the x-axis. So this is 4. So the rectangle is 4 high. And how wide is it? Well, it stretches from x equals 3 to x equals 7. So at 7 minus 3 is 4 wide. Okay, so this is a 4 by 4 rectangle, which is to say that it turns out in this case that our rectangle is actually a square. And so the area of our rectangle is 4 times 4, which is 16. And so that's it. That's the value of this integral. It is exactly 16. Okay. So there we go. That's our first example. Let's go ahead and do another example. So here, I want to do the integral from 0 to 4 of 2x dx. Okay. So this is a line of positive slope through the origin. So I know its graph is going to look, roughly speaking, like this. And now, if you're super attentive, you will notice that I started this by saying I'm only talking about positive functions, that is, functions that are above the axis. And this function definitely isn't positive. But really, all of everything I've said so far works as long as the part of the graph you're interested in is positive. And so the part of the graph I'm interested in is the part that goes from 0 to 4, and that's over here somewhere. And so everything I've said is going to work. I don't have to think about fancier things yet. Okay, so let's go ahead and label where 0 and 4 are. So here's 0. Here's 4. Okay, this is y equals 2x. Okay, and so the area I'm looking at here is this shape. Okay, and notice this shape here is a triangle. So in order to find its area, I'm going to need to remember the formula for the area of a triangle, which is 1/2 the base times the height. Okay, so the base here goes from 0 over to 4, so that is to say the base is 4 wide. Okay, and in order to get the height, I have to look at how high this point is, but this point is on the graph. Its x-coordinate is 4, so its y-coordinate is what I get when I plug 4 in. So this is 4, 8. So that is to say that it is 8 high. So the area of this triangle is 1/2 times 4 times 8, which is 16. The answer will not always be 16. It just happened this way. Okay. And do a couple more examples of this. Okay, so here we're going to take the integral from 0 to 2 of 2x plus 3 dx. So now in this instance, our line is of positive slope and has a positive y-intercept, so the graph looks something like this. So if I, again, let f of x be 2x plus 3, this is the graph of f of x. Okay. Here's 0, and then we'll go ahead and put 2 over here somewhere. Okay. And so this area of this thing is what I'm looking for. Now, you might at first be inclined to say, oh, this area, I don't even know what this is called. It happens to be a trapezoid if you don't remember your various random types of quadrilaterals from geometry. And so, well, of course, there's a formula for the area of a trapezoid, but you definitely don't need the formula for the area of a trapezoid in order to do this, because this trapezoid I can break into a rectangle and a triangle, and I can handle these things separately. Okay. So let's do the rectangle first. So this rectangle is 2 wide, and it's this high. How high is that? Well, that is 3 high, because it goes from the axis up to the y-intercept, and the y-intercept of my line is this plus 3. Okay. So the area here of my rectangle is 6. I also need to find the area of this triangle. So the width of the triangle is also 2. It's the same width as the rectangle. And then I have to think about what's the height of this. And so in order to figure that out, I can figure out the whole height. Okay. And so the whole height here, that's going to correspond to the y-coordinate of this point, which is going to be 2 comma f of 2, which is 7. So the whole height is 7. But then that height is 3. So that makes this height 4. Okay, so that means my picture is not very good, because this height is supposed to actually be bigger than this height, but I did it backwards. But whatever, all I needed to know in order to do a rough draft of the line, of the graph of the line, is that it was a line of positive slope and positive y-intercept. And so I can go ahead and figure out the area of this triangle. And so this triangle is 2 wide by 4 high, so it's 1/2 2 times 4, which is to say the area of this triangle is 4. And so the total area represented by this definite integral is 4 plus 6, which is 10. Okay, and so the answer to this question is 10. Okay, I want to do one more of these. Okay, and the one more I'm going to do is I am going to do the integral from 2 to 4 of 5 minus x dx. Okay, so here the line is 5 minus x, so it has a positive y-intercept and a negative slope, so its graph looks something like this. Okay. I know where the x-intercept is. It's at 5, because that's what makes 5 minus x 0. And I want to know the area here between 2 and 4. So here's 2, here's 4. So I want the area of this trapezoid thing in the middle again. Okay, this would be a great time to make sure that you understood the way we did this last time. So I would really recommend, before I do this for you, go ahead and pause and make sure that you can use the same idea that we did here in order to find the area of this trapezoid. All right. Now I'll go ahead and do it for you. But again, you should definitely have paused and done this yourself before we do it together. Okay, so I'm going to break this again into a rectangle and a triangle. The rectangle is 2 wide. And how high is the rectangle? Well, the rectangle has its height given by the y-coordinate of this point, and this point is 4, comma, and then what I get when I plug 4 into the function. So over here, this is my f of x. So when I plug 4 into that, I get 1. So this rectangle is 2 wide and 1 high. So that is to say it has area 2. Now, when I go to find the height of the triangle, I'm going to need to first find the coordinates of this point, which is 2, comma, 5 minus 2, so 3, which is to say that this height, it is the distance from the y-coordinate of this point to the y-coordinate of this point. So that is to say this height is 2. Okay. It would be 3 if I went all the way down to the axis, but I'm not because I'm stopping here, which is at a height of 1. Okay. And so that means the area of this triangle is 1/2 of 2 times 2, which is to say it is 2. And so then the total area of my trapezoid and also the value of this definite integral is 2 plus 2, which is 4. All right. We'll stop there for now. And next time, we'll talk about what happens when we look at functions that are sometimes negative. But until next time, be well.